characters that you don't think are, like, normal people don't think are attractive, and like, someone like Diego from like Dora, like, hear me out.
Hear me out. And they put him on a cake.
Yeah.
That's
like,
weird.
hear me out like Barney.
Chris Bird. Hear me out. Okay. Yep.
I put like little Batman on there.
All right, here we go. So you guys did a good job connecting that graph piece right at the end, but this question is, when is the particle moving in the positive direction? And it's moving in the positive direction when the velocity function is greater than 0. So when the velocity function is positive. And what I'm going to do is I'm just going to highlight these two spots where we see that the velocity function is positive. First of all, this is the velocity function, right? So it's positive there, where it's above the x-axis. That corresponds with the position function when the derivative is positive. Can we see how those two connect together? Okay. So, when is the velocity positive? What over what interval?
2.
Oh. Yeah. Hey, go away. Yeah, so we're going to go from 2 to infinity. Now we don't include the 2, just use a parenthesis. At 2, it's actually at rest, so it's not traveling to the right or the left. And then these last two questions, we go together. It says, find the total distance traveled for the particle over the course of the first 8 seconds, and draw a diagram to illustrate the motion of the particle. So let's just think about it. The particle starts. Does it start by heading to the left or the right?
Left.
Starts to head to the left, and then at how many seconds it changes direction?
2.
2 seconds it changes direction, and then it stops somewhere, right? So that's what it's doing, okay? It starts, moves to the left, and then to the right, okay? That's what it does. Now, if I'm at mile marker 13 right now for Albert Lee, if I go on the freeway, mile marker 13 for Albert Lee, right? 13. If I'm driving up to Owatonna, mile marker 43, how many miles have I traveled?
30.
But we kind of need to know our positions, don't we? So in order to figure out the motion of the particle, we want to consider where do we start, where are we when we change direction, and where are we when we end our travel. And we have those times and we have those positions to consider. So we consider the start, the change, and the end. Now we know we begin at time is equal to 0. And at what time do we change direction?
2.
2. And at what time do we end?
8.
8. It says over the course of the first 8 seconds. So what I'd like to do is I'd like to figure out where I'm located during those times. Right now we can see that S gives us position. Notice we've talked a lot about the velocity function right now, but it's actually the position function, the original one, that gives us our direct location. So we're going to use none other than t cubed minus 12t in order to determine our position. So we're going to plug 0 into that, and we plug in 0, you get
0.
So that means it starts at a location of 0. It's not always, it always starts at time 0, but your location won't always be 0. Like I said, if I take off from Albert Lee, I'm at position 13, headed up the freeway. Now I'm going to plug in 2. I get 2 cubed is 8 minus 24. I've got negative 16. So does that mean I headed off to the left or the right?
Left.
Left, because I got to encounter a negative value. So that makes sense with our drawing. And then I ended at time 8, so I'm going to plug in 8. 8 cubed is 512. And then 8 times 12 is 96. So we're going to subtract those and we get 416. Are we okay with that? So we will now draw the motion of this particle.
Well, we do not have that much.
We just used up a lot of the room.
Could we draw it up here?
Sure, yeah.
Good find.
Not motion. That sounded more fun in my head than what it is
So on my number line, I write the locations, and underneath I chose to write the times, so that way I know kind of where I'm going. I go from time 0 to time 2 to time 8. So the motion of the particle starts here, goes back to negative 16, and forward to 416. Now in this situation, we just had one time that it changed. It's possible we could have 2 times that it changes, and so you look at both of those. As I want to find this total distance traveled, notice in my first kind of interval here, I went 16 units to go from 0 to negative 16. And then I had 16 more units to go from negative 16 back to 0. And then I had, after that, I had 416 units to go from 0 to 416. So there's a few ways to think about doing this, but I'm going to look at it this way. And I get 448 feet.
Oh, yeah.
And that's my distance traveled. Okay?
So you have to do the bottom part first in order to do the top part?
I think it's helpful after using teaches that you would diagram it first and then use that to figure out the distance traveled. There will come a time in second semester, really about fourth quarter, where I teach you how to do this, where you actually don't even need to make the graph, but we need to learn a lot more calculus before we can do that. So I just would like to review finding the velocity. Is this difficult or easy?
Easy.
Because you just take the
Derivative of the
Yep.
feet.
Yep. This part, just plug it on in. When the particle is at rest, just solve velocity equal to 0 or look at the graph. Particle is moving the positive direction when the derivative is positive. And then finding the total distance traveled. Everybody agree that E and F could be a little bit more challenging?
Yes.
But I think we've outlined a good way in which you would solve for this. Please take out your homework so we can talk about your approach.
You want it?
Yep.
Oh, I got it. Okay.
So you've got just 2 problems on the front, and then you have 4 problems on the back. Right now, you just want to focus on problems 1 through 4. And I would say your goal is to come to class tomorrow with for sure problem 1 done. And feel like you have a general understanding. And then after this weekend, it would be really nice if you came back on Monday and had at least, I would say kind of gotten work and started on, say, 5 of those problems. So tomorrow we're going to do one where you use your calculator instead of just doing it all by hand. So you can see how that works. So you guys have time to kind of work away at that. Applications of derivatives. If you wonder where do we use derivatives, that's your first answer right here, is in motion type problems. So this is right up the alley of a physics type major. There you go. You guys have the rest of the time to work.